Hi everyone, welcome once again to another machine learning tutorial. In today's video, I am going to show you how you can use neural network models to predict malaria outcomes. So for this tutorial, we are going to build a neural network model and then use that to predict malaria outcomes. So that is what we are going to do. The data that I'm going to use is from this paper. I obtained it from this paper. And by the way, I am a co-author of this paper. In this paper, we use machine learning approaches to classify clinical malaria outcomes based on hematological parameters. For those who don't know, hematological parameters are measurements of the blood. They include hemoglobin levels, platelets, and then white blood cell counts. So that's about it. So for this tutorial, the notebook is publicly available. And if you want to run the notebook on your PC, you need to have these Python libraries installed. Alternatively, we can run everything using the Google Colab platform. For that, we need just our browser. So I'll show you how to do that. So first of all, go to my machine learning GitHub repo. I'll leave this link in the description box. So this is the link to the Python notebook we'll be using. So once you have this, just go to the open in Colab button, this blue button here, and then just click it. So click it, and then it will be open for you on the Google Colab platform. Before you run this notebook, you need to make sure you have signed into your Google account. It's important. Now let's proceed. I will switch to my notebook here. The first thing we have to do is to import our libraries. So I have some comments here to let you know what each group of libraries or models will do. So let's proceed. We are now going to read the data. So for this data, I have also made a copy available on my GitHub repo, and that is what we are going to use. So I'll use pandas to read that, and then I'll proceed to do some exploration and cleaning. Whenever you are going to do some machine learning work, it's important you explore the data. Data exploration will help you to understand the data, and it will also help you to, in some cases, identify the correct or the right or the appropriate methods for the downstream analysis. So here we are going to use the data frame, the shape, to get the number of samples and columns. So this is the total number of samples, 2207, and the columns here we have 34. We are going to proceed. I will get the first 5 rows for this data, and I have it here. So we have the columns here, and we have the entries here, so you can check them out. We can also list the columns themselves using this code here. I will do that here. So we have a number of columns here, sample ID, constant given, up to RBC list with percent. For this data, we are going to use a subset of it. And so we will do it here. We are going to take a subset. And so this code will help us to do that. So I'm using pandas still to do that. So we want the columns clinical diagnosis up to RBC list with here. Again, I repeat, we are going to use these columns from clinical diagnosis up to RBC list with percent. So that is somewhere here. Let's check here. This side and then this side. Okay, so that's what we need. So we are going to subset so that all these other ones, we omit them. So this code will help us do that. And after that, we are going to remove all rows with missing values. Missing values sometimes may affect your model negatively. Okay, they may have a negative impact on the model's performance. So it's always important to deal with that. So we are going to drop all rows with missing values. We use this code. Okay, so let's proceed. Let me check the shape here. I just want to check the number of samples and columns again. So I'll say subset.shape. Okay, so now we have this. Notice previously we had this number here. Okay, we did a subset, and then here, because we dropped some rows, okay, the rows with missing values, that is why the number has changed here. And here it's 18 because we did a subset, and then we use this column from this side up to this side, and that is why it's no longer 34. I think we had 34, yeah, but because some of them are not going to be used, we have omitted them. That is why we now have 18. So take note of that. For this data, the malaria outcomes or classes is in the first column, and the name is clinical diagnosis. So that is what I have here. So I'm going to display the categories, the various or the different malaria outcomes. So we have 3 of them here. So we have severe malaria, uncomplicated. We also have non-malaria infections. So that's it. So these 2 are malaria outcomes. This is non-malaria infection. So take note. So the point here is that we are going to feed the data to the neural network model, and then the model will identify patterns that can be used to distinguish between these 3 classes. So take note of that. We are now going to perform data preprocessing. Data preprocessing will help us to put our data in an appropriate format before we pass it to the machine learning model. We will first separate our labels from the features, so we are going to run this cell. Perfect. We are now going to encode our labels. At the moment, our labels are categorical, and therefore we have to convert them to numeric forms, and that is why we are doing the encoding. The machine learning model we are going to build require that our labels are given or supplied in numeric forms. So that is why we are encoding our labels. There are a number of encoding schemes available. For this tutorial, we are using the one-hot encoding. Let's run the code here to do the encoding. Perfect. So the final encoding is here. That one is here. So this is what we are going to use. For those who are new, let me show you an example of a one-hot encoding. So I'll just take the first entry here. So I'll say Y0. So this is the one-hot encoding. Now let's look at the original data. Subset clinical diagnosis. We will take the first entry. So I'll say .head n equals 1. That is severe malaria. Now let's look at all the labels, the original ones. So let's say labels. These are the original labels, the malaria outcomes. So with the one-hot encoding, we represent all these categories, and then we assign 0 to them, and then the actual label, we assign it a value of 1. So that is what we have here. So you can see that we have 3. Okay, so the 3 here represents these categories, and then the actual label, which is severe malaria, that one is here. That one is 1. Okay, so we give it 1. So that is how the encoding is done. I will make a separate tutorial where I go into details with one-hot encoding, so just stay tuned for that. So with the one-hot encoding here, if let's say you want the class, okay, you want the label, the actual label, the name, okay, and then it's in this format, what you can do is use the argmax method in NumPy. So we can say np.argmax, and then we give it our entry, and then we run it. So when you do it this way, you are going to get the index. Okay, so the argmax is giving you the maximum value, the max, which is 1. Okay, and it tells you the index. So the index here is 1. So if you have an index of 1, you can now come and then query it in the labels here. So let's say labels 1. And then you will now get the name itself. So this is how we do the encoding, and this is how we also make queries. Okay, so that's what we have. Now let's proceed. Let's proceed to the next activity. The next activity is to perform data splitting. We are going to split our data into 3: training, validation, and test sets. The training set is used for training. Validation set is used for evaluating the model during training. And then the test set is used to test the model after training and tuning has been completed. Okay, so that's what we do. In other words, we can say the test set is used to evaluate the model. So take notes of that. So we are going to split our data using the codes here. Perfect. So we have that done nicely for us. So let's proceed. So I have my training, validation, and then test sets. I am now going to perform data normalization. So here I am going to scale my data so that the values are between 0 and 1. This helps us to improve the model's performance and also avoid bias. So I will normalize. I am going to normalize the sets here, the data sets here separately. Okay, so this is done so that we can avoid data leakage. So I am normalizing them separately. So I'm using the min-max scaler to do that. So I'll run this cell. Perfect, that has been done. I'll now proceed to build the neural network model. So here I have 2 hidden layers and I also have an output layer here. So that's what I have. So I'm going to run this. You should know that the best architecture is obtained after doing experiments. You always need to experiment and then you get the best architecture or the best performing architecture. So for this exercise, I had to do some experiments and this is the architecture that gave me a good performance. So that is why I'm using this architecture. So take note of that. I also explain something here with the compilation. After building the model, you need to compile. So here the loss function I'm using is categorical cross entropy. This is because we are using a one-hot encoding scheme. So take note of that. And then the metrics I'm using categorical accuracy. So take note of that. Optimizer I'm using Adam. And notice I have also set a learning rate. So that's what I have. The learning rate can also be tweaked. So depending on what you want, you can use the default learning rate, or you can also specify your own learning rate. So all these things, these are experiments you have to do, and then you get the best architecture. So take note of that. So let's run this. Okay, now we are going to fit our model to the training data. So we use this to do that, and we also specify the validation data here. I have my batch size, I have my epochs, which is 200. And I also have verbose equals 1. Yeah, so the verbose equals 1 lets Python display some information for us. Okay, so information, we have the verbose equals 1 will let us know the accuracy and the loss as the model is being trained. So I set it so that we can see what is happening with the model. So we are now going to fit the model to the train data using this code. So I'll run it now. Okay, so training has started, so we can wait and then we'll see how it goes. Okay, the model has been trained. So let's proceed. After the model has been trained, it's important to visualize the model. Okay, we need to visualize and see how the model performed during the course of the training. And so we do that using this code here. So this code here will give us a summary and let us know how the model was performing, okay, for each epoch. So that is what we have here. So I'll run this to get the visualization. And now also get the one for the loss. This one is for the accuracy. Then this one is for the loss. So I'll display both. Okay. So let me just explain some few things here. So if you look at the accuracy, we see that the model improved. Okay, it was improving over time. So here we have the first epoch, and then as it moved along, the model was improving. So if you look at this model, this is how we expect a good model to behave. The behavior, I'm talking about the accuracy for the training and validation. Here we can see that the accuracy for the training and then that for the validation, the values are not far off. This is what we expect a good model to do. Okay, we expect that training and validation scores will not be that wide. The difference will not be that wide. If it becomes wide, then there's a problem. Okay, if it becomes wide, you need to investigate. And that is why this visualization is important, because it lets you know if your model is behaving as expected. So take note of that. We also have the loss, and we see that the values are not far off. So the model is behaving well. The behavior of this model is as expected. So we will proceed. And you can also check here validation and accuracy. We see the values here. Okay, around 0.83. Here the range is between 0 and 1, so around 0.83. Okay, so that's what we have. So with this plot, we can see that the model is performing well, because we can see it has a high score, 0.83, which is above 0.8, which is good. Okay, so now we are done with the training. And so we are now going to predict on the test data. Okay, we use the training and validation to initially train and then tune the model, but now we need to test this model on an independent data that the model has not seen before, and that is where the test data comes in. So we are going to do some predictions. I will write the codes here for us to see. Okay, so first of all, we are going to let the model do some predictions. And so we are going to use the model.predict method. So we say predictions equals model.predict. And then we give it the test data, which is x test. So we are going to do the prediction now. Perfect. The prediction has been done. So let's see. Let's just check predictions.shape. So you may be wondering why we have this 3 here. You may be expecting that since it's predictions, it's just one column. The predictions we have here are probabilities. Okay, so the probabilities are given for the different classes. We are dealing with 3 classes, so that is why we have it this way. So let's just take a look at one of them. Let's say predictions 0. So these are the probabilities. And so the class with the highest probability becomes the predicted class. So that is what we have here. So we can check the class here. We can say mp.addmax and say predictions 0. This will give us the index for the one with the highest probability. So here, the one with the highest probability is 2. That is this one here, 2. And so, if you do the inference, let's display the labels. 0, 1, 2. So that means that for this particular prediction, the model predicted that sample as what? Uncomplicated malaria. Okay, that is what it's predicted. Okay, now we can check the actual value or the ground truth, which is y test. Let's look at it. So the y test, let's say 0. Y test is what? 001. We can say np.argmax. That is what? 2. Okay, so interestingly, the model predicted correctly. Okay, the model's prediction was correct because it is 2, and the ground truth or the actual y label or the actual class is also 2, which is uncomplicated malaria. So that is what we have here. Okay, now we can combine all these codes to view the predictions for some of the entries. So let's look at getting the prediction for, let's say, the first 5 entries. We are going to write some codes here to do that. So let's do that. So this is what I'm going to do. I'm going to say for index entry in enumerate predictions. And then I'll say print predicted. And I'll say actual. And then when I come here, I'm using strange formatting. So I'll say np.argmax entry, and then here I'll say y tests, and it's also argmax, so I'll say np.argmax y tests index. So that is what I have here. So let's just cross-check to make sure that the code is okay. So I'll check here. Okay, everything is okay now. So I'll run this to get the predictions. Let me add this here. I just want to check the first 5, so I'll just do it here. I'll say 0 to 5. I want the first 5, so I'll do the predictions here. I'll display them. Perfect. So now we can see that here the predictions are correct because the actual labels are also the same. That's what we have here. Okay, so that's what it is. Okay, now let's proceed. Now we have some of the predictions. Now we are going to compute the accuracy. So take notes. The accuracy we got here is for the validation data set and then the training. Okay, but this time we want to get the accuracy for the model with respect to the test data. So we will do that here. So we will say loss accuracy equals model.evaluate, and then we say what? X tests, Y tests. So let's run this. Perfect. So we have it here. Now we can modify it. We can just say verbose equals 0 so that we don't see any text. Okay, so we have it this way. So now we can just query for the accuracy. Perfect. Okay, so we have 0.83, which is still a good score, okay, for this particular model. Okay, so now we have the accuracy for us. So with respect to the test data, I can see that the model is performing well, okay, for what we have done. Okay, now with neural network models, you can also improve them using other techniques, okay, and you can also evaluate using other metrics. One of the metrics you can also use to visualize the performance of neural network models is the ROC curves, and I have covered that tutorial as well, so you can just watch that using this particular link. So that'll be all for this tutorial. Thanks for watching, and I'll see you in the next session. Goodbye.